Welcome. In this session, let us try to understand the most basic construct of object-oriented programming, that is classes. So obviously, we will first try to understand what is need of object orientation. Then we will see how to write our basic class and how to create object from that class. We will also try to cover various concepts like constructors, properties, automatic properties, and destructors. So the very first thing that we should understand is what is the need of object orientation, or more specifically what is the need of class. We write softwares to automate real life processes, so obviously we need to represent real life entities in software. That means if you are writing employee management application, then you will need to store data about employees. We know that we have something known as variables to store data. So variables are memory locations where we can store data and from where programs can use that data. Every variable is of some data type like integer, float, character. These built-in data types are not capable to hold real life data. For example, if we will see employee entity in real life, you will observe that there are n number of things that we need to store about employee in our program. For example, employee number, name, salary, city. Each information is of different type. So if we wanted to store all this information using only basic data types or built-in data types provided by programming languages like integer, float, character, then we need to declare n number of variables. For example, here we have employee number of integer type, name of string type, then basic salary, HRA, DA, PF, gross salary of float type. So you can visualize it like this. We have created multiple variables to represent single entity of real life. So using this approach, you are not capable to represent single entity of real life as a single entity in digital world. This picture representation will clear you what I mean to say. So to come up with this limitation of basic data types or built-in data types, programming evolved to something known as structures. Now structural programming languages give you one keyword, struct, to declare your own structure or to create your own data type. For example, here we are creating struct employee with some fields like employee number, name, basic salary, HRA, DA, PF, gross salary. You can see that we have grouped up different types of data in single entity employee. Now this employee structure is what? It is nothing but data type that you have created. It is user defined data type. It is derived data type. Now as it is data type, you can create variable from this data type, employee emp. So this declaration will create variable in memory like this. So you can see that now emp is a single variable with n number of fields. You are declaring or you are creating variable from employee type same as you create from integer or float. Like you write int a or int b, same way you are writing employee emp. Only the difference is that int, float are the default data types provided you by languages, but employee data type you have created for your own usage as per your requirement. So now you are able to represent single entity of real world as a single entity in digital world. But again there is a gap between real world entity and digital world entity. That is what? Real world entity also have behavior. You can see in this picture representation that employee object or employee entity has structure, also it have behavior like employee is working. But in this representation you can see that it is only structure. It doesn't have any behavior. So in structural programming languages, we are able to represent single entity of real world as a single entity in digital world, but we don't have behavior inside that structure. So we have to write separate functions for the behavior of that entity in the programming language. And then whenever we wanted to execute that functionality, we have to call that functions, and we have to pass addresses of our structure variables. That is, there is no relationship between your structure and behavior. So to get programming more closer to real world, object orientation evolved and gave us legendary construct class. There are n number of other object-oriented concepts that we will discuss in respective sessions. Let us concentrate classes and objects in this session. So what exactly class is? It is nothing but grouping of structure and behavior that we have to write separately in structural programming languages. Here you can see that we have created employee class, and inside class there are fields same as in structures, but in addition to these fields there are also methods. Here you can see that there is calculate salary method which provides behavior to your object or to your variable. So again, to be very clear, employee is nothing but data type as you have created with struct keyword. But the difference over here is that before introduction of object orientation using struct, it was not possible to group up data and behavior inside your data type. So as employee is a data type, you can create variable of employee type. Now this is little syntactual difference of creating variable of this employee type. As we know that in C# there are two categories of variables. One is value type, another is reference type. So variables that we create from class are of reference type. That means they get created on heap. So to create that variable on heap, you need to use new keyword. So new employee will create variable in heap. You can see this variable with same fields, employee number, name, basic, and employee emp. This declaration will simply create a reference on stack. And what equal to is doing, it's just assigning address of this heap location to this reference variable. So if this location is 2000, that 2000 will go over here. This is how we create variable from class. But now as this variable, in addition to structure, it also has some behavior, we don't call this variable as variable, but we call it as an object. So object is nothing but variable only created from class. So to understand it better, let us have a look on one example. In this example you can see that there is one type employee, and inside that there are three private members: employee number, name, salary. We have used underscore as it is recommended practice to declare your private member as an underscore. Then what exactly private is? In object orientation, it is recommended that you should not give access to fields of your object from outside. For example, when you will create object of employee type, from outside this object should be accessed as an one entity and should not have access to internal fields of that object. So then if these are private members, then it is very clear that you will not have access to these members from outside world. For example, if you are declared E1 of employee type, here if you will try to say E1 dot, it will not give you access to underscore employee number, name or salary because they are private members. So then this object is of not any use until and unless you can interact with that object. So for this interaction, you need to provide public interface that you can provide using public methods. I am providing public interface read and display for this object. You can see that these are public methods. Read will just ask you to enter employee number, name and salary, and will assign respective member of that objects. Same way, display will print these details from the members of the object. Now you can call e1.read. Same way you can call e2.read to read the data in object, and then you can call e1.display and e2.display to output the information from the object. So now let us execute this program, and it will ask you to enter employee number, name and salary. Again, for E2 it will ask you to enter employee number, name and salary, and then display will display these details. So let us try to understand what exactly happening over here is using this graphical representation. In our program, there are two classes, employee and program. You can see this is employee class and this is program class. Inside program class there is main method, and in main method we have created two objects of employee type. Again, you can observe one thing over here, that I have used something known as this over here. So what is this? This is a reference variable of employee class. It is automatic variable. We need not to declare it. It is already there. So you can visualize it like this. There are two classes, employee and program. Inside program class there is main method, and in main method we have created two objects, say E1 with employee number, name, salary, then E2 employee number, name, salary. So this is because of new employee. This is employee E1 is equal to new employee. Okay, so you can see that this reference is over here in this. So E1 is basically name of reference variable which is referring to this object, and objects are anonymous. Objects on heap are always anonymous. Now when we will call e1.read, your control will go over here. At the same time, address of E1 or reference of E1 will go in this pointer. You can see, visualize it like this. When you will call e1.read, address of E1 or reference of this object which is in E1 will transfer to this pointer. And as this is pointing to this object, E1 object, when you will be inside a read keyword and asking for to enter employee number, name, basic salary, when user will enter employee number, it will go to this dot employee number, and this is pointing to E1, so it will go to E1 dot employee number, E1 dot name and E1 dot salary, and it will get populated with the values entered by user. Same way, when you will call e2.read, this reference of e2 will go in this, and this will start pointing to object E2. Now again you are in read method, but this time you have called read method using E2, so this contains address of E2, so whatever user will enter will go inside E2 dot employee number, E2 dot name and E2 dot salary. Same thing happen in case of this call. When you will call E1 dot display, inside this pointer reference of E1 will go, and you will come in display, and it will print E1 dot employee number, E1 dot name and E1 dot salary. Same way, When you call e2.display, reference of e2 will go in this and it will print e2.employee number, e2.name and e2.salary. Now the good thing is that you can always keep writing this keyword. It is fine if you will write it like this. Even here you can remove. So compiler will add it. So whenever you will use member variables of class inside methods of class, this pointer will automatically introduced by compiler before that member variable. I am sure that with this basic example, now you have good understanding about class, object and this reference variable. So now let us have quick look on the definition of class. A class is a construct that enables you to create your own custom types by grouping together variables of other types, methods, and events. A class is like a blueprint. It defines a data and behavior of type. Client code can use it by creating objects or instances which are assigned to a variable. So I think all these three statements we have already discussed. We have created class by grouping some variables and some methods. We will see all other stuff later. Class is blueprint for its object. So whenever we will create object E1, it will get all data and behavior that we have declared in class. Third, when you create object, what you do? You create object on heap and you assign its reference to the variable which is on stack. You create object on heap and you assign its reference to variable which is on stack. So these three important points about class. Same way, let us have a look on some important points of objects. An object is a block of memory that has been allocated and configured according to blueprint, typically class. So E1 is a block of memory which has been configured according to class employee, as it have structure, employee number, name, salary, and have behavior, read and display. A program may create many objects of same class, as we have created E1, E2 of same class employee. Objects can be stored in either named variable or in array of collection. Here you can see that we have stored this object in named variable. Same way we can store it in some array or collection that we will see later. Client code is a code that uses this variable to call methods and access the public property of object. So according to that statement, this is our client code where we have created object of that type and we are accessing public method of that type. In an object-oriented language like C#, a typical program consists of multiple objects interacting dynamically. This point means in object-oriented programming language, multiple objects communicate with each other to do specific job. This we can experience when the complexity of programs will grow in next few sessions. So now, having basic understanding about classes, it's right time to understand constructors. These are some important points about constructors that we should understand. Constructors are special methods with same name as of class, typically used to initialize data members of the new object. In this example, you can see that we have two constructors. You can observe one thing. The name of these methods are same as of class. This constructor, which doesn't have any parameter, is known as default constructor, as the constructor with some parameters is parameterized constructor. Constructors we generally use to initialize members of object. Here you can see that we are initializing employee number with 0, name with no name string, and salary with 0. Same way, here this parameterized constructor is initializing employee number with the value which we will receive over here in this variable employee number from client code. Same way, name we are initializing to the value which we will receive over here, and salary we are initializing with the value which we are receiving over here. So now how to call this constructor? Constructor will automatically get evoked whenever we will create object using new keyword. Your class can have multiple constructor. As we have seen, we have two constructor in our employee class. The constructor that takes no parameter is called default constructor, and if you will not provide any constructor, C# compiler will create one default constructor by itself. As we have seen in our previous example, we don't have any constructor, so C# compiler will create one default constructor for this class. But the rule is that if we will write one constructor, then no default constructor will be provided by C#. Then we have to write all the implementation of constructor that we want. That means if we will write parameterized constructor, then we also have to write default constructor. In that case, C#, if I have deleted this, then in this case C# will not create default constructor, as we have already specified parameterized constructor over there. Now this constructor will get called immediately after object creation. Means when we will create object in client code, like employee E1 is equal to new employee. New employee will allocate memory on heap for the object, and immediately after allocating memory on heap, constructor will get called. Listen my sentence carefully. Immediately after allocating memory on heap. That means we don't use constructor for memory allocation. So always remember that constructor will get called just after memory allocation. And then we will use this constructor just to assign some default value to member of that objects. So E1 will get assigned with this default value. In second instantiation, you can see that while creating E2, I am passing some parameters to the constructor. So this time parameterized constructor will get called, and this value will get accepted in these local variables of this method, that is employee number, name, and salary. These are local variables of this method. And then inside that constructor we will assign these values to the actual object. So we know that in this there is reference of E2. So E2 dot underscore employee number will get value employee number, and employee number contains 1. Same way E2 dot underscore name will get value John, and E2 dot underscore salary will get value 10,000. Let us run this program. These are the values for E1, 0, no name, and 0, and these are the values for E2, 1, John, and 10,000. In main method you have created E1 and E2, two objects. When you will create E1, it will call default constructor, and members will get initialized with 0, no name, and 0. Now when you will create E2, parameterized constructor will get called, and you will pass values to these local variables. This is a parameterized constructor block. Okay. Now when you will create E2, it will call parameterized constructor. As parameterized constructor is will get called by E2, so reference of E2 will get copied in this. Now whatever values you are passing as an parameter to this constructor will go to these local variables, so all values will come over here, and then you will assign it to employee number, this dot underscore employee number. So you are assigning EMP number to this dot underscore EMP number, this dot underscore name, and this dot underscore salary. So in short, you are assigning these values to members of E2 object. So now it should be very clear. Now the next very important member of class is what? Properties. Till then we have seen classes can contain private fields, public methods, then we have seen constructor. Same way, one very important member of class is property. A property is a member that provides flexible mechanism to read, write or compute the value for private field. Properties can be used as they are public data members. This enables data to be accessed easily and still helps promote the safety and flexibility of methods. Property have two accessors, get and set. Get we use to read the value and set to write the value to private field of class. If property do not have set accessor, then it is known as read only property. If property do not have get accessor, then it is known as write only property. And if property have both the accessor, then it is called read write property. So to understand all these points, let us again go through one simple example. Now, as we have seen in our first example, we have some private fields. To assign values to these fields and to access values from these fields, we have read and display methods. But the limitation of read and display method is what? They are tightly coupled with console applications. But as we will see in future, that your classes should not be tightly coupled with any particular type of application. So if you are writing class, it should be reusable in any type of application. You should be able to use in console application or Windows application or web application. It should not be tightly coupled with particular type of application. So it is not good practice to having console.writeLine or console.readLine statements inside class. Second limitation of these methods is what? Read method is reading values for all the fields of this class. Also, display method is displaying values for all the fields of that object. What if there are 30 fields and we wanted to display single field? Or what if out of 30 fields we only wanted to assign values to 2 or 3 fields? Then in that cases, read or display method will not help us. Then one solution is that you should write methods, public methods like read employee number, display employee number, read name, display name, read salary and display salary. So this way you have to write two methods for each member. This is how we do in C++. These methods are generally known as getters and setters. But C# provide you smarter construct known as properties, which reduces your code effort and also it makes your code more readable and maintainable. In this example you can see that again we have employee number, name and salary, all these private members with underscore. So for this private member, when I am creating public property, it doesn't have underscore and it is in capital case, so case difference is there. Now this property have two accessors, get and set. What get will do, it will just return value of actual field underscore employee number. Obviously this dot underscore employee number means current object. This will always contains reference of current object. Same way, in set, you can see that we are assigning some value to this dot employee number. Now what is this value? Value is a default variable of property. It is always there. We need not to declare it. Same as we have this reference variable for class by default, same we have value variable with property by default. Now same property can be written in this way so that it will take little space. For name, get is returning this dot underscore name, and in set it's assigning value to this dot underscore name. Salary, returning this dot underscore salary, and assigning, set is assigning value to this dot underscore salary. So when we will create object even, obviously it will have members underscore employee number underscore name and underscore salary. Here you can see that we are assigning value to employee number property. This syntax is not like a method call, but it is same as we are assigning value to some variable. But internally it will call set accessor of employee number property as you are assigning value to that property. So control will go to set accessor of employee number property, and whatever value you are assigning will be passed to this set accessor and get stored in value local variable, and that value you are assigning to this dot underscore employee number, that means even dot underscore employee number. Same is true in case of name and salary. Now surprisingly, when you will use same property in console.writeLine, it will call get accessor of that property as you wanted to access some value from this property. So even dot employee number this time will call get accessor, and get accessor will return you even dot underscore employee number value of that particular field, that is 1, which will get passed to writeLine method and will get printed over there on console. Same thing is true about name and salary. So in short, depending on what operation you are doing, automatically accessor of that property will get called. Whenever you will assign value to property, set accessor will get called, and whenever you will access value from property, get accessor will get called. If your property don't have set accessor, then that property is known as read only property, as you will not able to assign any value to that property. And if your property don't have get accessor, then that property is known as write only property, and you will not able to access value using that property. I think in this example we have cleared all these points. Whatever I have explained you can visualize using this figure. Here employee class, program class. In program class your main method with 2 objects, and when you will say e1 dot employee number, so address of e1 will get passed to this, employee number 1 will get passed to value, and that set accessor will get called and will assign that value to underscore employee number. Same way, when you will call e2 dot employee number is equal to 2, again address of e2 will get passed to this, so this will start pointing to object e2, and 2 will get in value variable which you will assign to underscore employee number of e2. One more important point about property is that you can use this property not only to get and set the values, but also to do some calculations, also to have some validations. For example, before assigning value to employee number, you can validate that value by putting some condition. Here you are checking that if value is greater than 0, then only you wanted it to assign to employee number. So this way you can put some validations. Also you can have some calculations inside properties. So automatic properties is relatively new feature introduced in C Sharp 3.0. It improves readability of your code and it also reduces your coding efforts. But automatic properties are only useful if you don't wanted to do any validation or calculation inside the properties. Here in code snippet, this is how we have to write our properties earlier. Private int underscore employee number, if this is our private field, we have to write public property with get accessor like this, which returns value of private field, and set accessor which assigns value to this private. You can replace this entire code snippet just by this one line. Public int emp number get set. That's it. Now compiler will convert in this code snippet. So obviously now your code will be more readable and you have to write less code. In this example you can clearly see the benefit of using automatic property. Now your class is less bulky. It is very beneficial if your class have 20-30 fields and you wanted to write properties just to get and set the values in these fields and you don't want to write any validation or calculations in that properties. And while using this property in client code there is no change, as this will get converted same as of your old thing, same as like this only. So all these statement will get converted like this. It will simply create one private member just by prefixing property name by underscore and property name with same as you have specified over here with get and set accessors. And the last thing that I would like to discuss over here is destructor. Destructor is a special method with same name as of class but prefixed by tilde operator. A class can only have one destructor. As we have seen, there can be multiple constructors, but destructor can be only one. Destructor cannot be inherited or overloaded. Destructors cannot be called. They are evoked automatically by garbage collector just before destroying the object. This is very important point. We will again discuss it in example. A destructor does not take modifiers or it doesn't have any parameters. Destructors are also called when program exits. Can be used to write cleanup code such as releasing unmanaged resources if used in class. So again, let us try to discuss all these points using one small example. Here we have class with 3 members and we are writing one destructor. You can see that this destructor has same name as of class. It doesn't have any return type. It doesn't have any access modifier like public or private, as we can't call it manually from client code. Okay, it is prefixed by tilde operator. Now what we can write inside destructor is some cleanup code. Now what is this cleanup code? Cleanup code is a code which is responsible to release resources. At this instance of time you may not get this point, but just keep in your mind that we can use destructor to release unmanaged resources. For example, if your object is using some network connection and just before destroying that object you wanted to make sure that that network connection should be released, then that code can be written in destructor. This is because your destructor will be always get called just before destroying your object. If you have provided any destructor in your code, it will be always called just before destroying your object. You should be very clear that destructors will not be responsible to destroy the object. I am repeating again, destructor will not be responsible to destroy the object. but they will get called by garbage collector just before destroying the object. As we know, in .NET, garbage collector is responsible to destroy the object. So we can use Destructor to write any code that we wanted to execute before destroying the object. Because if our class have Destructor, then garbage collector will check before destroying the object if that object have Destructor or not. If it have Destructor, then it will call that Destructor, will execute that code first and then come back and destroy the object. When garbage collector will destroy the object is not controllable by application developer. .NET have its own mechanism to call garbage collector. At this point we will only say that whenever there is no space to create new object in memory, then .NET will call garbage collector to destroy unreferenced object. Now I am saying unreferenced object. You should understand what exactly unreferenced object is. We know that objects always get created on heap. In this example, in main I have created E1, then I am calling fun1. So control will go to fun1. In fun1 we are creating E2. Then some code will execute, again control will come back. Now when control will come back, we know that variables that are on stack will get destroyed automatically as this function will go out of stack, but this object will remain over there in here. Same way again if I will call fun1, again new object will get created on heap, will be in E2. Again after completing the execution of fun1, when control will go back to main, again E2 will get destroyed. This variable, this variable on stack will get destroyed automatically as this function will out of stack, but this object will still remain in. So to make it very clear, you can use this graphical representation. Inside main we have created E1, then we have called fun1 where we have created E2. Now when control will go back to main, this fun1 will get removed from stack and with it all the local variables of that fun1 will go. But this object will remain as it is in heap. So this object is what? Unreferenced object. And when garbage collector will get executed on heap, it will destroy this object. And if your class have destructor, then before destroying this object, garbage collector will call that destructor, will execute that cleanup code, and then will come back and then destroy this object. So that's why I'm saying that inside destructor you can write some cleanup code. Also, when your program will stop executing, at that time also garbage collector will get called, also your destructor will get called. Just to demonstrate it, you can write over here console.writeLine. Now if I will run this program and just stop that program, you will see that on console there are some messages that have been skipped out that you will not able to see. So instead of using console.writeLine, I am using something system.diagnostics.trace.writeLine. Now what this trace.writeLine will do, trace.writeLine method will simply write this output on your output window. So you will able to see this message over there. Just run this program. Okay, and now let us stop this program. Go to output window and here you will see that your destructor has been called 3 times because your destructor was called thrice, as you are destroying 3 objects over here. One is this, and this object you are creating over here twice. You are calling fun1 twice. So there are 3 objects in heap which will get destroyed, and for each object destructor will get called. So this slide shows you basic object lifecycle. When you first create your object, memory will get allocated, then constructor will get called, then you will use that object in your program, then garbage collector will call destructor, and then it will destroy that object. So now with all these concepts in mind, let us see one demo example where we have put all this together. So in this demo example, instead of writing class over here, we have created separate file for the class. You just right click on this project, add class, and name it employee.cs. So one separate file will get created like this, and inside this employee class we have public methods employee number, name, basic salary, HRA, DA, PF, and gross salary. But here you can see that my employee number, name, basic salary are read write properties, but HRA, DA, PF, and gross salary are read only properties. We have declared set as an private to make it read only, because we don't wanted to assign values to HRA, DA, PF, and gross salary from outside the class. These will be calculated in the class itself. So client code will be able to only assign values to these properties, but will be able to read values from all these properties. Your default constructor doing nothing. This is your parameterized constructor, which is assigning employee number, name, and basic salary to these properties, and calculate salary method, which is calculating HRA as 15% of basic salary, DA as 10% of basic salary, PF as 5% of basic salary, and gross salary as addition of basic salary, HRA, DA, and deduction of PF. So this is business logic that you have in employee class. Now in client code you can create object of employee class, like employee1 is equal to new employee. You are assigning values to employee number, name, and basic salary. Then you are calling e1 dot calculate salary. So obviously it will call this method, will calculate HRA, DA, PF, and gross salary. We know that it will get converted internally like this dot HRA, this dot DA, this dot PF, and this dot gross salary. Same thing is true over here. This dot basic salary, this dot basic. So calculate salary will calculate values for all these fields, and then you can print all that data. You can see that you are using HRA, DA, PF, and gross salary properties in console.writeLine as they are read-only properties. But if you will try to directly say e1 dot gross salary, if you will try to assign some value to it over here in client code, compiler will not allow you, because set is marked as an private. That means it is read-only property. Again, you have also provided parameterized constructor in your class, so you can also create e2 like this. So here you are assigning values via property, but here you are assigning values via constructor to e2, and again you can call calculate salary, and same way you can print it. You can just go through this visualization. You have created e1 and e2 objects using properties. When you will say e1 dot employee number, you will assign employee number. Then when you will call calculate salary, it will calculate values for these fields, and then you will print e1 dot employee number, name, basic salary, HRA, DA, PF, and gross salary. Same thing when you will create e2 using constructor, you will assign values to employee number, name, and basic salary, and then you will display you will call calculate salary to calculate these 4 fields, and then you can display all these 7 fields using properties. So now good thing about this class is that It is not tightly coupled with any particular type of application, as it doesn't have any console.readline or console.writeline methods. So with this, I would like to stop over here. Thank you.